Hello friends, welcome back to Learning Nails and Aesthetics. We are continuing Chapter 6, Health and Public Safety, Chemistry and Chemical Safety. Surfactants are substances that allow oil and water to mix or emulsify. As such, they are one type of emulsifier. The surfactant molecule has two distinct parts. The head of the surfactant molecule is hydrophilic, capable of combining with or attracting water, water-loving. The tail is lipophilic, having an affinity for or an attraction to fat and oils, oil-loving. Following the like dissolves like rule, a chemistry rule of thumb describing how solvents dissolve chemically similar solutes. For example, water dissolves salt, but not oil. The hydrophilic head dissolves in water, and the lipophilic tail dissolves in oil. Thus, a surfactant molecule mixes with and dissolves in both oil and water and temporarily joins them together to form an emulsion. Did you know? Soaps were the first surfactants. People began making soaps about 4,500 years ago by boiling oil or animal fat with wood ashes. Modern soaps are made from animal fats or vegetable oils. Traditional bar soaps are highly alkaline and combine with the minerals in hard water to form an insoluble film that coats the skin and can cause hands to feel dry, itchy, and irritated. Beauty professionals who are performing nail services should be aware that soaps can leave a film on the nail plate, which could contribute to lifting of the nail enhancement. Modern synthetic surfactants can overcome these disadvantages and are superior to soaps. Many are milder on the skin than soaps used in the past. Oil in water, OW emulsions. An oil and water emulsion. Oil droplets are emulsified in water. The droplets of oil are surrounded by surfactants molecules and their lipophilic tails pointing in and their hydrophilic heads pointing out. Tiny oil droplets from the internal portion of each OW emulsion because the oil is completely surrounded by water. Oil in water emulsions do not feel as greasy as water in oil emulsions because the oil is hidden and water forms the external portion of the emulsion. Salons, spas, and barbershop use primarily OW emulsions. Oil and water. Have you ever heard the saying, oil and water don't mix? Pour some water into a glass and add a little cooking oil or other oil. What happens? Stir the water briskly with a spoon and observe for a minute or two. What does the oil do? Water in oil, WO emulsions. Water in oil, WO emulsion. Water droplets are emulsified in oil. The droplets of water are surrounded by surfactants, with their hydrophilic heads pointing in and their lipophilic tails pointing out. Tiny droplets of water form the internal portion of the WO emulsion because the water is completely surrounded by oil. Water in oil emulsions feel greasier than oil in water emulsions because the water is hidden and oil forms the external portion of the emulsion. Styling creams, cold creams, suntan lotions, and foot balms are examples of WO emulsions. Other physical mixtures. Ointments, pastes, pomades, and styling waxes are semi-solid mixtures made with a combination of petroleum jelly, oil, and wax. Powders are a physical mixture of one or more types of solids. Off the scalp, powdered hair lighteners are physical mixtures. These mixtures may separate during shipping and storage and should be thoroughly mixed by shaking the container before each use. Did you know? Mayonnaise is an example of an oil and water emulsion of two immiscible liquids. Although oil and water are immiscible, the egg yolk in mayonnaise emulsifies the oil droplets and distributes them uniformly in the water. Without the egg yolk as an emulsifying agent, the oil and water would separate. Most of the emulsions used in a salon, spa, or barbershop are oil and water. Hair color, shampoos, conditioners, hand lotion, and facial creams are oil in water emulsions. Common chemical product ingredients. Beauty professionals use many chemical products when performing client services. The following are some of the most common chemical ingredients used in beauty and wellness products. Volatile alcohols. Evaporate easily, such as isopropyl alcohol, rubbing alcohol, and ethyl alcohol, hairspray, and alcoholic beverages. These chemicals are familiar to most people. However, there are many other types of alcohol, from free-flowing liquids to hard, waxy solids. Fatty alcohols, such as cetyl alcohol and cetyl alcohol, are non-volatile alcohol waxes that are used as skin conditioners. Alkylamines are alkaline substances used to neutralize acids or raise the pH of many hair products. They are often used in place of ammonia because they produce less odor. Ammonia is a colorless gas composed of hydrogen and nitrogen that has a pungent odor. It is used to raise the pH in hair products to allow the solution to penetrate the hair shaft. Ammonium hydroxide and ammonium thioglycolate are examples of ammonia compounds that are used to perform chemical services. Glycerin is a sweet, colorless, oily substance. It is used as a solvent and as a moisturizer in skin and body creams. Silicones are a special type of oil used in hair conditioners, water-resistant lubricants for the skin, and nail polish dryers. Silicones are less greasy than other oils and form a breathable film that does not cause comedones, which are blackheads. Silicones also give a silky smooth feeling to skin and a great shine to hair. Certain silicone resins, silicone gums, can withstand high pH environments and can be incorporated into hair relaxers and permanent wave formulations. Volatile organic compounds, VOCs, contain carbon, which is organic, and evaporate very easily, volatile. For example, a common VOC used in hairspray is SD alcohol. Volatile organic solvents such as ethyl acetate and isopropyl alcohol are used in nail polish, base and top coats, and polish removers. Did you know silicone, Si, is an element like carbon, C, and oxygen, O, that has a metallic appearance and is widely used in the electronics industry? Do not confuse it with silicones, which are compounds made with silicone and other elements. Silicones are used in a variety of personal care products, including hair care, skin care, and nail care products. The overexposure principle. You may often hear the word toxic. People tend to think of a toxic substance as a dangerous poison. However, the toxicity of a substance is related to how it is used and how much of it is used. The truth is, everything on earth is toxic to some degree. There is nothing in the world that is completely non-toxic. The very word non-toxic is a made-up marketing term that has no precise scientific meaning. Overexposure refers to how prolonged, repeated, or long-term exposure to certain product ingredients can cause sensitivity in some people. The overexposure principle is used to describe how overexposure determines toxicity. It holds that it is the poisonous effect on the body. For example, salt water is very toxic to drink, yet you can safely swim in the ocean without fear of poisoning. Similarly, rubbing alcohol is quite toxic. A tablespoon can poison and kill a small child. However, it is safe to use on the body and when kept out of reach of children. Toxicity does not mean a substance is automatically unsafe. Instead, it tells you that you must be sure to use it in a safe manner. To understand how to safely use and handle your products, review the manufacturer's safety data sheet, SDS, for important safety information. Check in. What are the differences between solutions, suspensions, and emulsions? Give examples. Describe potential hydrogen and how the pH scale works. Although pH, an abbreviation of potential hydrogen, is often mentioned when talking about beauty products, it is one of the least understood chemical properties. Notice that pH is written with a small p, which represents a quantity, and a capital H, which represents the hydrogen ion. The term pH represents the quantity of hydrogen ions. Understanding the pH and how it affects the hair, skin, and nails is essential to understanding all beauty and wellness services. Water and pH. Before you can understand pH, you need to learn about ions. An ion is an atom or molecule that carries an electrical charge. Ionization is the separation of an atom or molecule into positive and negative ions. An ion with a negative electrical charge is an anion. An ion with a positive electrical charge is a cation. Some water, H2O, molecules naturally ionize into hydrogen ions and hydroxide ions. The pH scale measures these ions. The hydrogen ion, H+, is acidic. The more hydrogen ions there are in a substance, the more acidic it will be. The hydroxide ion, OH-, is alkaline. The more hydroxide ions there are in a substance, the more alkaline it will be. pH is only possible because of the ionization of water. Therefore, only products that contain water can have a pH. In pure distilled water, each water molecule that ionizes produces one hydrogen ion and one hydroxide ion. Pure water has a neutral pH because it contains the same number of hydrogen ions as hydroxide ions. It is an equal balance of 50% acidic and 50% alkaline. The pH of any substance is always a balance of both acidity and alkalinity. As acidity increases, alkalinity decreases. The opposite is also true. As alkalinity increases, acidity decreases. Even the strongest acid also contains some alkalinity. The pH scale. The pH scale is used to measure the acidity and alkalinity of a substance. It has a range of 0 to 14. A pH of 7 is a neutral solution. A pH below 7 indicates an acidic solution. And a pH above 7 indicates an alkaline solution. However, 1 point of pH difference is more than it looks. Start over. However, 1 point of pH difference is more than it looks because the pH scale is a logarithmic scale. A change of one whole number represents a tenfold change in pH. This means, for example, that a pH of 8 is 10 times more alkaline than a pH of 7. A change of two whole numbers represents a change of 10 times 10, or a 100-fold change. So a pH of 9 is 100 times more alkaline than a pH of 7. Even a small change on a pH scale represents a large change of the pH. pH is always a balance of both acidity and alkalinity. Pure distilled water has a pH of 7, which is an equal balance of acid and alkaline. Although a pH of 7 is neutral on the pH scale, it is not compared to the hair and skin, which have an average pH of 5. Pure water with a pH of 7 is 100 times more alkaline than a pH of 5. So pure water is 100 times more alkaline than your hair and skin. This difference in pH is the reason pure water can cause the hair to swell as much as 20%. pH and skincare products. When the skin is exposed to extremes in pH levels, dryness, dehydration, inflammation, and even bacteria can grow in the product is incorrect for a given skin type. Let me start over. pH and skincare products. When the skin is exposed to extreme pH levels, dryness, dehydration, inflammation, and even bacteria can grow if the product is incorrect for a given skin type. It is important to use products that contain the proper pH for a given skin type. For example, if a client has dry, dehydrated skin, give that client a product that is too acidic. If a client has dry, dehydrated skin, giving that client a product that is too acidic could further dry and irritate their skin. Conversely, if a client has an oily type, a product that is slightly alkaline may contribute to oil and sebum buildup and possibly create acne. This client may need a product with a more acidic pH. Acids and alkalis. All acids owe their chemical reactivity to the hydrogen ion. Acids have a pH below 7. Alpha hydroxy acids, AHAs, derived from plants, mostly fruit, are examples of acids when used to exfoliate the skin and help adjust the pH of a lotion, conditioner, or cream. Acids contract and close the hair cuticle. One such acid is thioglycolic acid, a colorless liquid or white crystals with a strong, unpleasant odor that is used in permanent waving solutions. Glycolic acid is an alpha hydroxy acid used in exfoliation and to lower the pH of products. All alkalis, also known as bases, owe their chemical reactivity to the hydroxide ion. Alkalis are compounds that react with acids to form salts. Alkalis have a pH above 7. They feel slippery and soapy on the skin. Alkalis soften and swell hair, skin, the cuticle on the nail plate, and calloused skin. Sodium hydroxide, commonly known as lye, is a very strong alkali used in chemical hair relaxers, callus softeners, and drain cleaners. These products must be used according to manufacturer's instructions. It is very important that you do not let these products touch or sit on the skin, as they may cause injury or a burning sensation. Sodium hydroxide products may be especially dangerous if they get into the eyes, so always wear safety glasses to avoid eye contact. Consult the product's SDS for more specific information on safe use. Activity. Product pH. For a product to have a pH, it must contain water. Shampoos, conditioners, hair color, permanent waves, relaxers, lotions, and creams have a pH. Divide into groups and use the internet to find the pH of these products or of others found in your school. If the information is not available online, contact the manufacturer of the product. Make a chart and compare your findings with your classmates. How will the pH of these products affect the hair or skin? Here is a hint to save you some time. Oils, waxes, and nail polish have no pH because they contain no water. Check in. Define pH and draw a pH scale. Summarize neutralization and redox reactions. Two types of chemical reactions are of particular importance to beauty professionals because they explain how major beauty products work. They are acid-alkaline neutralization reactions and oxidation-reduction reactions. Neutralization reactions. Acid-alkali neutralization reactions occur when an acid is mixed with an alkali in equal proportions, balancing the total pH and forming of water, H2O, and a salt. Neutralizing shampoos and normalizing lotions used to neutralize hair relaxers work by causing an acid-alkali neutralization reaction. This stops the relaxing process and returns the hair to its natural pH level. Similarly, slightly acidic liquid soaps can be used to neutralize alkaline callus softener residues left on the skin after rinsing with water. In both of these examples, the neutral pH of the hair or skin is recovered, an important step in beauty services that returns the body to equilibrium. Redox reactions. Oxidation reduction, also known as redox, is a chemical reaction. I'm sorry, I got distracted. There's a spider on. Anyway, also known as redox is a chemical reaction in which oxidation and reduction take place at the same time. When oxidation is chemically combined with a substance, the substance is oxidized. When oxidation is chemically removed from a substance, the substance is reduced. An oxidizing agent is a substance that releases oxygen, hydrogen peroxide, H2O2, which can be thought of as water with an extra atom of oxygen, is an example of an oxidizing agent. A reducing agent is a substance that adds hydrogen to a chemical compound or subtracts oxygen from the compound. When hydrogen peroxide is mixed with an oxidation hair color, oxygen is subtracted from the hydrogen peroxide, and the hydrogen peroxide is reduced. At the same time, oxygen is added to the hair color, and the hair color is oxidized. In this example, hair color is the reducing agent. So far, we have considered oxidation only as the addition of oxygen and reduction only as the loss of oxygen. Although the first known oxidation reactions involved oxygen, many oxidation reactions do not involve oxygen. Oxidation also results from loss of hydrogen, and reduction also results from addition of hydrogen. Redox reactions are also responsible for the chemical changes created by hair colors, hair lighteners, permanent wave solutions, and thioglycolic acid neutralizers. These chemical services would not be possible without oxidation reduction reactions. Exothermic reactions. When certain chemical reactions release energy in the form of heat, it is called an exothermic reaction. An example of this is the heat produced after mixing the activator and waving lotion is an exothermic permanent wave product. When the activator, which contains hydrogen peroxide, is added to the waving lotion, an oxidation reaction occurs that produces heat. The mixing of these chemicals produces a more rapid form of oxidation than the slower oxidation that occurs with permanent wave neutralizers or oxidation hair color products. In most cases, you can expect to feel a slight warming of the container after mixing the activator with the wave lotion. Another example of an exothermic reaction is a nail product that hardens, polymerizes to create nail enhancements. In fact, all oxidation reactions are exothermic reactions. Combustion is the rapid oxidation of a substance accompanied by the production of heat and light. Lighting a match is an example of combustion. Oxidation requires the presence of oxygen. This is the reason that there cannot be fire without air. Endothermic reactions. An endothermic reaction is a chemical reaction that requires the absorption of energy or heat from an external source for the reaction to actually occur. Melting ice is an example of an endothermic reaction. If the ice were not absorbing heat from its surroundings, it would not be melting. Another example from the world of hair care is a permanent wave solution that requires the application of heat from a hood dryer to activate it for processing, rather than processing at room temperature. These are called endothermic waves. Check-in. Explain neutralization reactions and why they are an important part of beauty services. Practice chemical safety. Considering all the types of chemicals used daily in the salon, spa, and barbershop, along with all their potential actions and reactions, practicing chemical safety should be a primary concern. From transporting to disposing of chemicals, you must be aware of the risks involved and the processes needed to ensure safety. Although it may seem time-consuming and complicated, reading the labels of all the products you use and understanding how to safely handle them are important parts of being a beauty professional. Labels. Manufacturers of chemicals that are registered with either the EPA or FDA are held to strict standards for their labels. These require that all hazards be disclosed alongside specific cautions and directions for use. It is unfortunate, but many people do not read product labels yet are shocked when they have a bad outcome. For example, using hydrogen peroxide in higher concentrations or applying heat to accelerate a service can cause severe chemical burns. It is vital that you always follow label instructions to avoid dangerous and painful situations. And that is the end of this video. We will continue Chapter 6, Health and Public Safety, Chemical and Chemical Safety. And I apologize for my mistakes, but I'm not a bot. So that's how it is sometimes. Please like, share, and subscribe, and add a comment, even if it's just a smiley face. That would be great. I'd really appreciate it. I do have several other videos coming. We have some unboxing that we've already done and going to do some more. I will be starting also the Milady books on aesthetics and nails. And I appreciate your support. Thank you very much. Have a great day. Bye.